Hey everybody, so we're going to do problems 11, 14 to 18 today. I'm going to take it all in one video and I'm going to do it all in one problem style. There are a few really good questions at the beginning of 14, and then we're going to move into notes for a 2-sample difference in means with t. So let's get going on that. The context is Latavia's oranges. Again, I think we've done one of these before. Latavia from problem 10-32 is at Fresh Foods again, looking at the oranges. This time she notices that Fresh Foods has both organic and traditionally grown oranges. She buys an organic orange and notices that it's not as juicy as traditionally grown oranges she has had before, and she decides to investigate. She buys a random sample of 30 traditionally grown oranges and 30 organic oranges from the Fresh Foods display, takes them home, gets out her electric juicer, and measures the volume of juice from each orange in milliliters. A, is this an observational study or an experiment? Okay, so we're kind of on this observational study versus experiment thing lately. This one is an observational study. She is simply juicing the oranges and taking measurements. She is not influencing them in any way. And also, the biggest way you can tell is because the context of the problem says random sample and not random assignment. And because it says random sample, that means that our independence condition is going to be the usual times 10. Okay, B. Assuming Latavia discovers the difference in the juice volume, to what population can she reasonably extend her conclusion? Okay, so all of the oranges that she got were from that particular Fresh Foods. So her population would be all of the oranges at that Fresh Foods store. Other fresh food stores might have oranges from a different farmer, a different supplier, so they might have different measurements. C. Latavia wants to see if organic oranges have less juice on average than traditionally grown oranges. Explain why it would not make sense to conduct a t-test using paired values in this case. Okay, so this is really one of the things I wanted to touch on. Why is this 2-sample and not paired? And the reason is because the oranges in sample 1, the organic oranges, are not the same oranges that are in sample 2. So there are different oranges in sample 1 and sample 2. You do not have half an orange being organic and half an orange being traditional, and you can take the juice from half of each side and then subtract. So they're completely different oranges in sample 1 and completely different oranges in sample 2. The comparative box plot and summary data for Latavia's investigation are shown below. Use your gut. Do you think that Latavia has statistically significant evidence that the average volume of juice from organic oranges is less than the average volume from traditionally grown ones? Okay, so I'm scrolling down. I would say no, there is way too much overlap in the box plots to just assume a difference. Okay. Now in this spot, I am going to write down the the summary calculations. So this is the organic and then traditional. Alright, so this is going to help me in my hypothesis test. Okay. E. Latavia wants to perform a hypothesis test with a null hypothesis. The mean volume of juice from the organic oranges is the same as the mean volume of juice from the traditional oranges. And the alternative hypothesis, the mean volume of juice from traditional oranges is higher than the mean volume from organic oranges. How could she write these null hypotheses in symbols? See if you can come up with two different ways. Hint, one of them will involve a difference. Okay, so this is the last thing we're going to do before we do the notes, and I do want to show you kind of how to write hypotheses. This is exactly like chapter 8. If you remember, we had P1 minus P2 equals 0, and P1 minus P2 is greater than, less than, or not equal to 0. This is the same thing, but the book is easing us there, so they gave us language. The mean volume of juice from organic oranges, okay, so that's mean organic, is the same as the mean volume of juice from traditional oranges. Okay, and the alternative hypothesis is the mean volume of juice from traditional oranges is higher than the mean volume from organic oranges. Okay, what we're going to do is rewrite these into the null and alternative hypotheses that we're actually going to use in the problem. These do not have a difference in them, so remember you can minus from both sides. So I have, and I'm actually going to switch this around. And then I'm going to minus this from both sides. Okay, so this is the null and alternative hypotheses that we want to use. Okay, so for everything else, we're just going to do notes here. So notes, this is 11-15 through 18. Ooh. Okay, so we have a hypothesis test for a two-sample difference in means, mu1 minus mu2. Okay. Identify. Okay, so for the identify, you will want null and alternative hypotheses, which we already came up with. You want your alpha value, and you will want statements for the context of mu1 and mu2. In this case, I'm using O and T for organic and traditional. I am looking to see if there's an alpha value suggested later on. Nope. Okay. Alright, so mu t minus mu o equals 0. For these, it's really great. The null hypothesis is always the same. It's equals 0 every time. Because you just want to know if there's a difference or not. So you're saying there's no difference here, and then greater than 0. This you need to figure out from the context, which if you remember from chapter 8 was kind of tricky. 0.05. Okay, the mean volume of juice from organic oranges, the mean volume of juice from traditional oranges. Okay, great. Okay, conditions. Now, if you remember from chapter 8, this is a little bit annoying. You have to check for both samples separately. Okay. Alright, so looking back in the problem, it says both of these were a random sample. We touched on that back in 11-14a, where we said it was an observational study because it had the words random sample. Okay, now independence, because it's a sample and not assignment, I have to actually do the independence condition. There were 30 traditional oranges. Okay, so remember we stated the population was only the oranges at that fresh food store, so 30 times 10 equals 300, less than or equal to all traditional oranges at that fresh foods. 30 times 10 equals 300, less than or equal to all organic oranges at that fresh foods. Poor large counts condition is losing all of his room. Okay. Large counts condition, 30 is greater than or equal to 30, so CLT applies. 30 is greater than or equal to 30, so CLT applies. Great. Calculate. Okay, so we are in a hypothesis test situation here. So bringing up my formula packet, I have standardized test statistic. In this case, it's going to be T. I do not have any idea what the population means or standard deviations are. I am going to estimate my parameter being 0 here, but I do not know anything about that, so I need to use T, not Z. Okay, now the statistic in this case is the difference. So notice it says 2 sample difference in means. I'm going to copy this for my statistics. So I have traditional minus organic. So I'm going to do my statistic is T bar minus O bar. So traditional sample minus organic sample mean. okay, minus the parameter, which is 0, which is what we have written in the null hypothesis, over, okay, and the standard error of the statistic is found right here. So it says for two populations, so we're working with two samples, x bar 1 minus x bar 2, and you want this. So you have st squared over nt plus so squared over no. Okay, and we are going to put those things in. So 33.1333 minus 31.6167 over just want you to notice in this formula why this works this way. So you're squaring the standard deviations to make them into variances, and this used to be standard deviation over the square root of n, so now this giant square root creates that square root of n on the bottom, and then this process of squaring and then taking the square root gets you to variance, allows you to combine and then get back to standard deviation, which is pretty cool because that's all in one formula. Okay, and we have 1.844. I highly suggest that you guys type this in your calculator. Pause the video, take a second, type this in your calculator, and make sure you get 1.844 because this is kind of feisty right here. Okay, and p-value, TCDF is positive, so I'm going to go 1.844 to positive infinity. Okay, now here's the next question that you have, and that is, what the heck is the degrees of freedom in this case? What you want to do is be conservative, so degrees of freedom equals n minus 1 for the smaller sample size, the smaller of two. So let's say this sample size was 50 and this one was 20. You would take the smaller one of the two and go n minus 1. So your degrees of freedom would be 19 in that case. They're both equal in this one, so 29. If any of you guys are super nerdy, and if you remember that formula I was telling you about earlier to calculate degrees of freedom, that super complicated formula, the book has included it in 17b if any of you want to look it up, but that is not required, and just wanted to point that out. Okay, and so this comes out to be 0.0377, which is great. Since our p-value of 0.0377 is less than 0.05, yay! We reject the null hypothesis. Okay, so it seems like the juice from traditional oranges is greater than organic. And of course we know that we're only talking about this particular fresh foods store. Okay, thanks everybody. I'll come back soon for problems 22 to 24.